we have the two device A and device B, but these two devices now have four interfaces. Or we can say that these two devices, because we are using the Ethernet cable or twisted pair cable, these two devices has, for example, have the 8 wire, but they are using only 4 wire. It's better. Look at here, the pin 1. This is pin 1, this is pin 2, this is pin 3, this is pin 4, this is pin 5, okay, then pin 6, then pin 7, okay, and then pin 8. That's it. Let me to remove it. I'm going to talk about it with more detail. It's so important to understanding everything completely with all of the details. Look at here. Here, as you can see, we have device A. In device A, as you can see, we have 8 pins, but we are using only 4 of these 8 pins, because we are using the Cat5 or, for example, Cat3, okay, in the first days of the networks. Again, here we have the same, for example, pins. Let me to write here. This is the pin 1 again. This is the pin 2, pin 3, pin 4, pin 5, pin 6, pin 7, and pin 8, okay. And we need a cable to use this cable to connect these two devices to each other. Some of these devices, for example, network interface card and, for example, other devices such as the router, are using the 2 of these 8 pins for send and 2 of these 8 pins for receive. Let me to write here. It is important to know the network interface card, okay, are using the pin 1 and 2. Pin 1 and 2 means these 2 pins for transmitting, because we need a complete circuit. I will show you. And also, for example, the hub and also in the NIC we are using the pin of the 3 and 6, okay, for receive. This means that we don't use pin 4, 5, 7, and 8, okay, but the direction is reverse in the hub and switch, okay. In the hub and switch we are using pin 1 and 2 for receive and pin 3 and 6 for the send, okay, also in the switch. Let me write here again, pin 1 and 2 for the receive, and let me write here, and pin 3 and 6 for the send. But in router, again, we have the same pinout such as the NIC. Let me write here, pin 1 and 2 for send, and then, for example, the pin 3 and 6 for receive. This is the default pinout. You can change it, okay? And assume that this is a network interface card. This is a network interface card. And this means that we are using the pin 1 and pin 2 for send, pin 3 and pin 6 for receive. And also here we have one, for example, switch, as you learned before. How we can connect this switch to this, for example, network interface card. Let me to write here the pinout first. It's important to understanding everything correctly. The pin 1 is using for TX. Let me to write TX plus, and this is TX negative. I will show you the circuit of TX plus and TX negative, but for now let me to use TX plus and TX negative. Also, we are using the pin 3. This is the pin 3 for RX plus, okay, RX plus, and also pin 6 for RX negative. You know that the pin 4, pin 5, pin 7, pin 8 are not using. Why? Because we are using now Cat5 or Cat3, for example. In network interface card, as I mentioned before, we are using pin 1, 2 for send and pin 3 and 6 for receive. But in the switch, we have the reverse direction. Let me write here. In the switch, we are using the pin 1 for receive, pin 2 for receive, pin 3 for send, and also pin 6 for send, okay. This is the pinout. Again, we don't use pin 4, 5, 7, and 8. How we can connect these two devices? I'm sure that you can easily say this, the method, we can connect the pin 1 of the switch A of the network interface card or device A to the pin 1 of the switch. Why? Because this is the send pin in switch A and this is the receive pin in switch B. Because of that, we can connect these two interfaces directly to each other. And again, we need to connect this port pin 2 of the switch of the network interface card A to the switch B, and then again pin 3 to the pin 3, and also pin 6 to pin 6. It's so easy. Also, let me to connect other ports to each other, because the other port doesn't do anything. Let me to connect them. This means that we are connecting all of the pins of these two devices to each other. And now we have, again, as you can see, one straight cable. This is the straight cable, okay, or a straight through. Let me to write the more academic name of this cable, a straight through cable. Okay, what does it mean? It means that when you are connecting the RJ45 to these cables, you need, for example, to connect one of these colors to pin 1 of the RJ45 and the same color on the next side to the same pin. For example, let me to write here. You know that in one twisted pair cable we have some colors. For example, blue. This is a blue color. The blue color wire in one side, in one RJ45, should connect, for example, to pin 1, and in the next side also to pin 1. Okay, and after that, other colors also should be connected with this, with the same function. Look at here, 2. Okay, this is 2, 3, 4, 5, 6, 7, and 8. Let me to show you here. For example, the pin 2, okay, and pin 3 and pin 4, 5, 6, 7, 8 should connect to directly pin 2, 3, 4, 5, 6, 7, and 8. But how? It's easy. You need to connect, for example, use one of these colors for and connect the pin 1 in each side to that color. This means that we are connecting pin 1 to pin 1, because when you are using the blue wire in one side connecting to pin 1 and in another side to pin 1, this means that we are connecting pin 1 to each other. For example, for another pin, we can use another color, for example, brown. Okay, let me write here brown. Okay, and the next pin can be connected with the orange, and then with the for example, green, and then after that we can use the white blue, okay, or white orange, or for example, let me write here the next color, white green. Okay, and finally the white brown. Maybe you say that the colors are the colors optional? We can use any color for connecting each pin. The first answer is that yes, if you want, you can use any color, but this is not a good option. Why? Look at here. As you can see in this twisted pair, we have different twists between these pairs. As you can see here, we have less twisted pair, and here we have, for example, more twisted pair, because we have some standards about the crosstalk and some other features related to communication. And with that standard, okay, it's better, according to that standard, it's better to using special colors, okay, for the pin 1 means the send pin, or for pin 2, pin 3, and some other pins. Because of that, although you can use these colors, but it's better to using a special and a specific, for example, order of the colors for connecting different pins to each other. Let me to talk about that. We have a standard. We call it EIA /TIA 568 A and B. Okay, the first thing is that what is the EIA/TIA? EIA is the abbreviation of the Electronic Industries Alliance, and TIA is the abbreviation of the Telecommunication Industry Association. It's not important for us, but here we have one standard 568 A and B that is received from these two companies, these two organizations. Okay, What is this standard? This is the order of the colors when we are using the, for example, twisted pair cable. In a standard 568A, we have these colors. I will talk about the function of and usage of these colors, but let me to say that in a standard of the 568, we have this order of the colors. As you can see, the first color means the pin 1 color is the white green, as you can see here. The pin 2 is green, the pin 3 is white orange, the pin 4 is blue, the pin 5 is white blue, the pin 6 is orange, the pin 7 is white brown, and the pin 8 is brown. Okay, this is a standard of 568. And in a standard of the 568B, okay, this is the first, we saw the standard of 568A. Now I'm going to talk about the 568B. In 568B, everything is same, only we need to reverse the place of the green and orange. Look at here, white green now change to the white orange, green change to the orange, white orange change to the white green, but the blue is same, white blue is same. Again, orange change to the green, white brown is same, and brown is same. Okay, look at here, white orange, here we have white green, green, here we have orange, white orange, here we have white green, blue and the white blue are same, and then orange converted to green. Okay, and after that white, brown, and brown again are same. Because of that, now we know about two standard, 568A and 568B. This is two standard about the Pinout. Okay, now let me to talk about what is the relation of these two standards to